Can you start now? Okay. Okay, good morning and good day to all audience and viewers from Masa University Facebook page and YouTube channel. Welcome to the webinar conducted by Faculty of Engineering, Built Environment and IT of Masa University. My name is Balpreet Kaur. I am an IT student in Masa University and I will be serving as your moderator today. Today, we will be hearing a presentation from Associate Professor Dr. Muhammad Nizam Ayub. Associate Professor Dr. Muhammad Nizam Ayub received a degree in BSc Computer Science majoring Computer Systems and Networking from University of Malaya, Kuala Lumpur, Malaysia in 2000 and a master degree in Interactive Multimedia from Heriot-Watt University, Scotland in 2001. He graduated his PhD degree in ICT in education from the University of the West of Scotland in 2016. His research interests include serious game, multimedia technology, and image processing. Without further ado, I would like to welcome Associate Professor Dr. Muhammad Nizam Ayub, who will be speaking to us with topic Natural Interaction of Game-Based Learning for Elasticity. All right, Dr. Nizam, the floor is yours.
All right, thank you very much, Balpreet, for the warm introduction. All right, so again, my name is Nizam Ayub. I'm a lecturer at University Malaya. So I've been teaching here since, I think, for the past 20 years already. And basically, today, I would like to talk about, I've been asked actually, I've been requested to do some presentation on the research that I did previously. So basically, I'm more into serious game. So when we are talking about serious game, basically it is a game that having a purpose. It's not purely for entertainment. Like we can find a serious game as well, which is commercially on the shelf as well. Let's say, for example, people using World of Warcraft, so which is to teach about management skill. So because World of Warcraft basically, when we are talking about the most massively multiplayer online role-playing game in term of subscription, so World of Warcraft basically is the largest subscription that they have. Right. So today's topic is about natural interaction of game-based learning for elasticity. So when we are talking about natural interaction, what is natural interaction basically? Natural interaction is just like when we are talking with another people. So we are using gesture, we are using verbal communication. So it's just like you asking uh, your Siri or Alexa in your mobile phone to talk or to call somebody. It's just like they have it as well in in vehicle industry as well. So which you give a command through through speech, or it can be some sort of verbal communication. It can be some sort of non-verbal communication. So non-verbal communication, probably we need to have a mechanism to capture the movement. So the movement that's shown by the player, so that is what we are capturing. So in this research, basically we are using Kinect. So some of you might be wonder, because Kinect basically is been not continued by the Microsoft for several years. So recently they are coming back because of Microsoft Azure platform. So they merge into Microsoft Azure platform. I'll show you some example as well, uh, how Sky TV in UK also adapt the use of Kinect in what they call a Sky Glass. Right. So basically, this research it is funded by UMRG. UMRG stand for Unistream Layar Research Grant. So it's been, I think, it's been conducted for the past, it's for the last 3 years basically. So when we are talking about game-based learning is a subset of serious game. When we are talking about serious game, there is a lot of purpose. People using serious game. They use serious game for propaganda. So this is example. Uh, uh, American Army. American Army is most the successful propaganda where they want to intrigue young American to join an army. So they use this so as a propaganda. So people would like to play the game. At the end, they want to join the army as well. So there's a lot as well. A serious game funded by UNICEF. So where they give awareness campaign. Let's say for example, when Utopia having a civil war. So they create a game which called Darfur is Dying. So which is to help people in Utopia to give awareness about what happening in Utopia, how difficult it is to get a food, for example, as well as we might come across a lot of game as well about awareness about population, about pollution, sea pollution. For example, we are playing a game to act as a turtle because turtle cannot differentiate between a plastic bag and a jellyfish. A jellyfish is a food for the turtle, but because we are throwing plastic bag into the sea, and turtle might eat the plastic as well. Right. So in this research, basically, we try to adapt game-based learning to be used in volatile environment. So when we're talking about elastic object, so that can be considered as the hazardous, is a hazard. The bouncing ball, for example. So which is we try to create a game where we allow young children age 8 years old, or even below that, to interact with the elasticity object. So, for example, a bouncing ball. So when we allow this young kid, 4 years old, 5 years old, to play with the ball outside, yes, it is a good exposure, but at the same time, we need to have a close monitor. So the guardian or even the teacher need to be there. So but when we try to use this as a mechanism where they can interact, they need to understand what type of object which are having elasticity material, or some object which is not elasticity in term of material. So we try to investigate the interaction between learners and elastic object naturally in safe environment using GBL. And we use Kinect technology. As I said earlier, Kinect technology, I think Microsoft would not like to continue that at some stage. Why? Because augmented reality come into the market. They want to produce a lot of devices which incorporate augmented reality rather than total virtual reality. So let's say, for example, if we are creating a game using Kinect, so it is all virtual reality. So it's can be part of augmented reality as well. But since augmented reality is the hype, so this big company as well would like to introduce it. Let's say, for example, Google also invests a lot in HoloLens, Microsoft as well. So they compete among them uh, to gain a large portion of the market of augmented reality segment rather than virtual reality. So that's why Kinect was left behind at some stage. The procedure comprise of detecting the gesture body and defining the meaning of gesture, which is exhibit during the learning process. So when young children interact with this application, they can interact freely. So which is they can move their hand, they can move their head, they can move their hip as well. So which they can see whenever the object touch the body on the screen, and they can differentiate whether the object have the elasticity material, so which they can play around and as well as score some point. Right. So coming back to natural interaction, it exists when people interact with the system the same way as we communicate daily. So this include expression, gesture, various intonation, movement. Let's say, for example, we have text, a voice activation or voice recognition. So when we give a command, let's say, for example, you have a smart home in some stage, or even now at your home. So we are giving command. Let's say, for example, light on or light off. So this is the same thing when you're giving command to your X70 car, for example, your Proton car. So when you're giving command, the computer will translate the speech or the voice of the person and compare it with the database. And when we are talking about differences, of course, there will be a lot of differences because when we are giving command, we also bounded by the mood of the day. Let's say, for example, we just having argument with our boss, and when we come home, we tend to speak louder, or maybe in angrier mood. So it might not match with whatever saved in the database, what as the reference for the command to be executed. And natural interaction, basically, we can use Kinect. Kinect is a mid-body gesture. What is mid-body? Meaning it can be half, it can be full as well as the gesture is a natural interaction. And the best thing about using Kinect, of course, is also incorporate a 3D, because they have a 3D camera beside that. We also giving command through voice assistant or voice activation by our Alexa or Siri, as well as mobile phone or tablet, which is using touch as well as multi-touch. Right. There is a lot. As I said earlier, when we are thinking about Kinect, is this up and down of the Kinect? So Kinect uh, was continued in 2017 for several years. Microsoft uh, don't want to continue. One thing, of course, there's a lot of console based coming in, and they have the initial project, so which is a project Natal, which was announced in 2009. Uh, if I'm not mistaken, Steven Spielberg also joined when they start launching the Kinect, and it hit the market because of console base. Basically, people would like to have this during Christmas time, and quite a large number of Kinect was sold at the first year, and it was continued for several years before it discontinued in 2017. And they try to revive back. So Microsoft want to revive back the Kinect with because when people see there's a lot of potential of Kinect. Let's say, for example, in creating application, let's say for rehab, for example, rehabilitation, people use Kinect for rehab purpose, as well as they use Kinect for measuring performance by athlete. And because of this, the number of people would like to use as a game based or game console at home, they are getting reduced. So that's why uh, as well as I said, the augmented reality come in. So people like to use going towards augmented reality rather than virtual reality. And how there is a link here. So how do I click the link? Yeah. So this is example of. Can I zoom in? So I don't know whether you have that. I won't able to click it. So this is example of Skyglass. It was launched, I think, in 2021, if I'm not mistaken. So this is recently technology introduced by Sky TV in the UK. So where they incorporate Kinect, reside on the TV. So which they can receive a command through voice, they can receive a command through gesture as well. Uh, and it was partnered with Microsoft in order to come out with Skyglass. If you share it with the audience later on, perhaps they can click on the link as well. Right. So coming back to the natural interaction in game, so it can increase the cognitive and cybernetic dynamic of the player because they can interact freely as well as they can express themselves much easier because the way of communicating, the way of interaction is not through a device or a dedicated keyboard. So Mac machine adapted to human language in terms of sensation, presentation, as well as narration. And because we communicating with the device or with the apps, with the application through gesture, movement, as well as expression. And it reduce the cognitive load of the subject because they don't have to learn how to control the keyboard. They don't have to learn how to control the mouse. For some young kid, probably they might have difficulties in sort of hand-eye coordination as well. And the effectiveness of multimedia game that which involve human body movement is more than those which are not involve human movement in terms of physical activities, movement, as well as enjoyment. And at the end, we want our player to engage with the content. So when we are talking about serious game or game-based learning, basically we need to firm with the objective of it. So in any education or in any learning process, so we need to have the objective. So in this case, the objective is to teach them how to interact with the elasticity object. So they can see the object that having the elasticity material can be bounced back when it hit the body, any part of the body. So that is the most important part. We engage them through the movement, through the expression, to the physical activities, uh, intrinsically towards the content. And this is the design and development process basically. So we are using Microsoft Kinect SDK. So now we can download Microsoft Kinect Azure framework SDK as well. And so this is the link where you can download it. So which it's using a GitHub Azure Kinect sensor. And for those who are on early stage of using Kinect, there is a Kinect SDK, so which you can download it to be used with Scratch. So I don't know whether you familiar with Scratch or not. Scratch basically was developed by MIT to teach young kid how to do programming. So it's just like a Lego base. So which they match based on the color as well as the Lego brick, the combination of that. And they also which you can download the SDK for to be used by Scratch. So which is also relatively very simple. And the API control audio and video data stream, skeletal tracking as well as player. This is example of the screenshot. So we just use a wireframe, even though we can provide with the uh, actual image of the player, but we are using a skeletal base because it's much easier to for young children to interact with. So whenever they move their hand, so we can see the part of the hand is also moving. And we also having a point base elasticity object. So we if you notice here, we are not using the object that can be quantified as the material elasticity material. Let's say for example, we are not using ball, we are using square, we are using star. So this is where they can learn how in any object that having elasticity, so when it touch a part of the body, so it will bounce back. So when the when let's say for example, when the red square hit the body, so it will start bouncing. So the player need to control the bouncing of the red square in order not to falling down. So this is the concept. So we don't introduce or we don't use the actual object that they recognize as the elasticity or made from elasticity material. And so we divided the result into two categories. So which is 7 to 9 years old as well as 10 to 12 years old. And we allow them to have several attempts. And then we can see uh, when they familiar with the environment, when they familiar with the interaction, how to control any elasticity material or elasticity object. So the score are getting higher. So this is for 7 and 9 years old. So this is 12 to 10 to 12 years old. So we can see the differences between this, between 7 to 9 years old, as well as from 10 to 12 years old. So this is the score, the actual score that we recorded during the experiment session. And as conclusion, so it is can be considered hazard for children to learn about elasticity object in real life environment, as well as we might have difficulties for the teachers to closely monitor during the process of uh, during the process where the people interact with the elasticity object. We tend or we try to create a safe environment for the children to learn about elasticity material. And for this research, because we are using Kinect, so we found out that Kinect is an effective device for educational purpose, and the result is also confirmed toward that, as well as children enthusiasm of interacting with Kinect. So that is also part of the uh, result that drive this research basically. And I think this we come across to the last slide actually. There is several link. So because I'm not able to click it, so uh, you can click it at your own time. So the first one is some paper, the recent one, so which is using Kinect uh, as a medium. So when we are talking about serious game or even game development, I'm also teaching game development. Beside Android, beside a mobile base, of course, mobile base is the largest thing in term of business wise. So that is the largest portion. and as well as we can use Kinect. So especially when we are talking about to develop a serious game. So Kinect, it is a huge potential. People use Kinect to train. People use Kinect to monitor the progress of the athlete. So that's the same thing actually when we are using Wii, for example, Nintendo Wii. Yeah? So which is because Wii is where you need to have a device or towards your hand as well as for the PlayStation. Yeah? And there is a link as well about research in Kinect. Yeah? And Kinect is also when we are talking about recent in term of multimedia research, people talking about metaverse. So metaverse basically is it is I would say is a virtual world, so where we can interact with other people. So it's just like if you're familiar with Second Life, if you're familiar with Neverwinter Night, so this is where you can create your own avatar and you can interact with others. So we can use Kinect as well in order to capture the movement as well as uh, that will be exhibit by the avatar. And I think the last link is about Kinect sensor. So that is a future trend as well as the research, the latest research challenge. And there is a huge area so for Kinect to be used. So a lot been used in medical, especially for rehabilitation. Uh, People who have having the operation, for example, so they use Kinect to train themselves. Uh, Definitely to be used in entertainment, so for social interaction as well as for education, and it can be used in many more. So let's say, for example, in training, education, including training, for example, specialized training. We are using Kinect, for example, so which is to let's say to be used in can be used in oil and gas industry as well. So I can see that people who train and then we can capture the movement as and we can evaluate as well. Uh, so that is I I want to share some of link. So this is can you see my screen now? Uh, can you see?
Can doctor?
So can I open the tab actually? If I'm open the tab, is it? Can you see it? Yeah. So right.
No,
This
cannot.
is a tab. No, it's not moving.
No. It came back to the presentation slide.
So this is game development. So this is a third year course for multimedia student in University Malaya. So basically, we are teaching about game development, especially it's not meant for any, I would say, in for any platform. It's not meant for mobile based. It's not meant for web based. It's not meant for Kinect. So we teach everything, including development for iOS. And there's topic on Android development, Unity, but the main is about the uh, collision, because in any game, the graphic is quite important, as well the graphic, whether you're creating your player, your enemy as well, and then we also teach about the collision in uh, game programming, collision is the most important part because that dictate the whole, uh, I would say, the whole gameplay, how the gameplay will be. And we introduced about serious game as well. And some part of the uh, syllabus actually. So we also teach about Kinect development. So which is this is where I'm saying Kinect for Scratch. So which if I'm open this one, can you see this?
No, cannot.
Cannot. It's still stick in there, right?
Mm.
Never. So I'm not sure whether if I open any link, so it will also pop up in your screen. So in term of student final year project, several project we provide Kinect, the camera itself to be used by the student for their project. I think we have several in our unit. I think 10 unit, up to 10 unit, if I'm not mistaken. So which is so the student are free if they would like to explore or to use Kinect for their final project, so they can use it. And some of them use because the recent paradigm of game programming. So they use a lot of Unity instead of using pure programming on C Sharp, and they can use Unity as well, integrate it with Kinect. They have a in Unity as well. They have a Kinect API to be used. So you just link it, and then it can interact with the camera itself. They can capture the movement as well as you can put it in the game that you develop. Right. So that's I think so that's the wrap of my presentation. So I hope it could broaden your view, especially when we are using when try to use Kinect to be part of your research. Yeah? So even though some said Kinect was dead as because it was not continued at some stage by Microsoft, and now it's coming back. But of course in different platform lah, in Azure platform, but you can easily download the SDK to be used in your research, to be used in the programming. All right, I think that's it for the presentation.
Okay, Doctor, before we end, I would like to ask some questions.
Yeah,
May
sure.
I?
Yeah, sure, sure.
Okay, so based on the presentation just now, may I know what are the challenges you faced on game-based learning for your research?
So, if you are talking about the challenge, so to be used in game-based learning, uh, because the most important because we are not educator, we are not teachers, because we are relying on for the feedback from the teachers, especially because the teacher actually they the one who interact with the student, and the mechanism or the approach of the, we are comparing with the traditional approach as well. If you're talking about traditional approach, I also did a research, a game development. It is a history subject. Japanese invasion in especially in Kelantan or
Oh, okay.
in layer, but towards Kelantan lah because the first Japanese come in, they landed in Kota Baru, isn't it?
Yeah.
And if we compare it with the syllabus as well as how teacher teach in the classroom as compared for the game, the most important challenge is we try to understand how teacher deliver the content, as well as we use when we try to use game. There is a lot of uh, I mean, at the first stage, we have difficulties as well, to adapt it in the classroom, because one thing it is uh, the pessimist reception, when we're talking about we want to introduce game in the classroom. So that is the teachers are not really open into this idea at the beginning. So
Oh,
because
okay,
game is
okay.
always associated with fun, it's sometimes it's associated with bad behavior, sleep late at night. So all those bad uh, ideas was thrown to the game, and when we try to use game-based learning, it also uh, infected. uh. So that is the most
Oh,
challenge,
okay.
I would say, in any game-based learning uh,
Um,
development. Yes.
oh, okay. Okay, thank you for answering my question. So, we have come to the end part of the presentation. Thank you very much, Associate Professor Dr. Muhammad Nizam Ayub, for addressing this interesting topic and for sharing this session with us. Hopefully, the presentation was beneficial for everyone. On behalf of Masa University, we would like to thank you for joining us today. Thank you for your time and cooperation. Thank you,
No,
Doctor.
no, it's a pleasure for me. Thank you. Not a problem.
Uh,